In this video, we are going to continue with another topic in plane in space, which is how to find the angle between two planes. And the second one is how to find the angle between a line and a plane. Now we go to the first one, which is how to find the angle between two planes. Let's say we have two planes, denote as so the first plane denote as pi1 and the second plane denote as pi2. So for a plane, we know that it has a normal vector that is orthogonal to a plane. So this will be a normal vector of plane 1, and the second one, this will be the normal vector for plane 2, which is orthogonal to plane 2. So the idea is to find the angle between two planes. This angle between two planes is defined to be the angle between their normal vectors. So we can find the acute angle that is between pi1 and pi2 as here. So the theta here is the angle between two planes. So another side, this will be 180 minus theta. Or if I show you in terms of 2D perspective, so this will be our plane 2 and this will be our plane 1. Then our normal vector of plane 2, which is n2, is like this, and our normal vector of plane 2 will be something like this. It's 90 degrees from the plane 1. So this will be 90 degrees for plane 2. So what we can find is the angle will be is here. So our aim is to find the angle between these two planes by using the angle between the normal vectors. So to find the angle now, we can use the formula, which is cos theta equals to the dot product of the normal vector 1 and normal vector 2 divided by the magnitude of normal vector 1 times with the normal vector of magnitude. So this is the formula to find the angle between two planes. There are also some cases where two planes are parallel. Let's say we have the plane 1 is here. So the normal vector of plane 1 will be like this. And then the second plane, which is pi2, so the normal vector of plane 2 will be somewhere like this. So we can prove that, or we can show that these two planes are parallel if and only if the normal vector 1 is equals to a constant lambda times with the normal vector 2. So if this is achieved, it means that these two planes are parallel. Okay, another thing is that there are also a case where the planes are orthogonal to each other. So this is the first plane, and the normal vector will be somewhere like this. And this is the second plane, and the normal vector will be somewhere here. So in order to show that these two planes are orthogonal, it must satisfy that the normal vector of 1 dot product with the normal vector of 2 must be equals to 0. So if n1 dot n2 equals to 0, means that these two planes are orthogonal. Let us try this first example. Find the angle between the planes minus x plus y minus z equals to 2. So this is the first plane. And 2x plus y minus 4z equals to 3. So from the plane here, the equation of plane, we have the first plane is minus x plus y minus z equals to 2. As we know, equation of plane is equals to ax plus by plus cz equals to d, where a, b, and c are the normal vectors. So now we can identify the normal vectors of plane 1, which is equals to negative 1, 1, negative 1. And then for the plane 2, the equation of plane 2, which is 2x plus y minus 4z equals to 3. So from here, the normal vector of plane 2 is equals to 2, 1, negative 4. So we have identified the normal vector for each plane. So what we need to do next is we can find the angle between the planes. We know that the formula for angle between two planes is given that cos theta equals to n1 dot n2 divided by the magnitude of n1 multiplied with the magnitude of normal vector 2. So first what we need to do is we have to find the dot product of n1 and n2. So the dot product will produce a scalar. So first this will be our normal vector 1, which is negative 1, 1, negative 1, dot with normal vector 2, which is 2, 1, negative 4. So we multiply this. First multiply the first row, which is negative 1 times 2, plus with 1 times 1, plus with negative 1 times negative 4. Then we have this negative 2 plus 1 plus 4. So this will be equals to 3. Okay, the next thing is that we have to find the magnitude of normal vector 1. So the magnitude of normal vector 1 is equals to the square root of negative 1 square plus 1 square plus negative 1 square. So we have it is equals to 3. Then we find the magnitude of normal vector 2 using the same method by finding the square root of 2 square plus 1 square plus negative 4 square. So here we will have equals to square root of 21. So then we have find all this, the important thing here. So we just substitute back into the formula. So our cos theta will be equals to the dot product of these two normal vector, which is 3 over the magnitude of normal vector 1 times with magnitude of normal vector 2, which is 21. So we can find that theta is equals to the cos inverse of this, which is equals to 67 degree 47 minutes, or it is equals to 67.79 degree. The answer can be either these two. Now we try to solve the second example. Show that the planes 2x minus 3y minus z equals to 5. So this one we denote as plane 1. And 6x minus 9y minus 3z equals to 2. This is as plane 2 are parallel. So as I said earlier, in order to show that the planes are parallel, we have to make sure that the normal vector 1 is equals to lambda normal vector 2. So in order to do this, what we need to do is we have to identify the normal vector for each plane. So for plane 1, where this is equals to 2x minus 3y minus z equals to 5. So from here we can obtain the normal vector, which is taken from this constant, where the normal vector 1 is equals to 2 minus 3 minus 1, or we can write it as 2i minus 3j minus k. And then from plane 2, where the equation of the plane is 6x minus 9y minus 3z equals to 2, so the normal vector 2 is equals to 6 negative 9 minus 3, or 6i minus 9j minus 3k. So now we want to make a comparison, or we want to check whether n1 satisfy this equation. n1 and n2 satisfy this equation. So our n1 is equals to 2 minus 3 minus 1 equals to lambda n2, which is 6 minus 9 minus 3. So I'll just rewrite this formula. Okay, so now we check first one by one. So 2 is equals to lambda 6, where lambda is equals to 1/3. So for y and z, it should be, we should get the same lambda. So to check this, so we just equate this equation. So minus 3 equals to negative 9 lambda. So lambda will be equals to 1/3. Same goes with the last one. Minus 1 equals to minus 3 lambda. So lambda will be equals to 1/3. So means that for x, y, and z, for I, j, k, lambda is equals to 1/3. So n1 equals to 1/3 of n2. So this means that the planes are parallel. Another method to show that the planes are parallel is that we can use the formula of cos theta equals to n1 dot n2 divided by the magnitude of n1 times with the magnitude of normal vector 2. So to find this, we have to find the dot product of n1 and n2, which is equals to 2 minus 3 minus 1 dot with 6 minus 9 minus 3, where this is equals to 12 plus 27 plus 3, which is equals to 42. Then we find the magnitude of n1 and n2. So we have the magnitude of n1, which is equals to the square root of is 2 square plus negative 3 square plus negative 1 square, and we will have equals to Z14 and the magnitude of N2, which is equals to Z of 6 square plus negative 9 square plus negative 3 square, which is equals to Z126. So then we just substitute all this value into the formula. So we have our cos theta is equals to 42 divided by square root of 14 times with square root of 126. So when we want to find the theta, which is the inverse cos of this value, so we get theta is equals to 0. So since the theta is equals to 0, it is shown that the planes are parallel. Because if you try to draw a parallel plane, so this will be the pi 1 and this will be our pi 2, and you can see that the normal vector for plane 1 and the normal vector for plane 2 are equals to 0. So it means that the planes are parallel. So there are two methods in order to solve this. Okay, it's either you can use the simple method where you just have to prove that n1 equals to lambda n2, or you can use the formula of cos theta equals to the dot product of n1 and n2 divided by the magnitude of n1 multiplied with n2, and the theta will be equals to 0.